Hello, this video explains how to answer question 3 of this Edexcel A Level Maths Mechanics paper, and the video will end with what the mark scheme says on the subject. This question involves topics from Year 2 Mechanics Chapter 5, Forces and Friction, and also Year 1 Mechanics Chapter 10, Forces and Motion. Part A. In order to find the normal reaction, we need to use our diagram to label on and resolve the forces involved in the described situation. The mass of the particle is m, so we can mark on the weight mg. We want the normal reaction r, so to find it we need to split the weight into its component parts. One will act this way and the other will act this way. If this is a right angle triangle, this is 90 minus alpha, so this is alpha. I'll do a separate video on resolving forces if you need that detail, but for now I'll label on the components of mg. mg cos alpha and mg sin alpha. Let's get to the bottom of what sin alpha and cos alpha are. We're given that tan alpha is 5 over 12, and we know that in a right angle triangle, tan is opposite over adjacent. So if we draw a right angle triangle and label 5 and 12 on it, we can use Pythagoras' theorem to get the hypotenuse, and then we'll be able to say that sin alpha is 5 over 13, and cos alpha is 12 over 13 from our right angle triangle. So from our force diagram we can see that the normal reaction equals mg cos alpha, and we know that cos alpha is 12 over 13, so therefore the normal reaction is 12 over 13 mg newtons. Part B. P is sliding down this rough plane. Let's put friction on the diagram. This is acting up the slope. We know from Newton's second law that F equals ma. Mg sin alpha, the component of the weight, is leading P down the slope, and this is held back by friction, which we know equals mu r. So we can use r from part A to write this. Sin alpha is 5 over 13, so we can now write this. If we then divide both sides by m and factorise the left-hand side by taking 1/13 g out as a common factor, we get the equation for acceleration. When you see the mark scheme at the end of this video, you'll see that the required answer to part C is that P wouldn't move. To explain this though, you look at the equation we found in part B, and we see that when mu is 5/12, that A is 0, so P wouldn't move. If mu is greater than 5/12, we see that mg sin alpha, which is 5 over 13 mg, will be lower than friction, which is 12/13 mg mu. So again, P wouldn't move. And here's what the mark scheme says about the question. If you want more walkthroughs on other questions from this paper, then have a look in the mechanics playlist. Thank you very much for watching.